The next key condition that enabled life to develop on Earth was the temperature range that we find on Earth. Okay, so the temperature range is on average about 15, 16 degrees. And this means that the temperature ranges between, in most areas, between 0 degrees centigrade and 35 degrees centigrade. Now, this temperature range means that it's warm enough for liquid water to exist, and there's a diversity of conditions for different types of life to evolve into, and it means it's not hot enough to denature proteins or enzymes, which are key biological molecules. Without these working properly, we don't have life being able to develop as we understand it. The next thing is then atmospheric gases. Okay, so atmospheric gases include things like, so if we have the surface of the Earth, so here's the surface of our Earth, and then there's our oceans. Our atmosphere is full of, or the early atmosphere at least, was full of gases like CO2. It had water vapor. It had things like ammonia, and it had methane gases in it as well. And it was like this thick atmosphere full of these, what we'd consider toxic gases. You'll notice there's no oxygen at this point. So it's what we call an anoxic environment. Okay, and this is really important because it means that we have what's called a greenhouse effect that takes place. Because the incoming solar radiation, the insolation, as it comes in, some of it is reflected off of the Earth's surface, and it is absorbed by these gases which heat up. So CO2, methane, water vapor, they all absorb the reflected energy and then re-emit it, warming the planet. Some of it's emitted back into space, but a lot of it is trapped and helps warm the Earth. And this prevents us from getting too cold, and it means we're warmer than we otherwise would be, helping to promote liquid water. These gases also contain really important elements for life, so carbon, oxygen, nitrogen, hydrogen. In the presence of things like lightning, with its really high temperatures, we can get things like amino acids being produced, and these are like the building blocks for life. Okay, so that's why these sort of early atmospheric gases are important for the development of life. Not life as we know it now necessarily, because there was no oxygen, but life in general. The next one is solar insolation. So we've talked a bit about solar insolation in our last lesson. We talked about how the sunlight coming in is sort of dictated by how far away we are from the sun, and also the rotation of the Earth and the tilt of the Earth's axis. But the insulation that we get into the Earth's surface is affected by the Earth's surface albedo. Okay, and let's have some mountains here with some snow on them. Okay, so this is the Earth's surface. We got some normal sort of levels. We've got some rocks there and some snow and the sea. And insulation coming in from the sun, so here's the sun, is reflected to differing amounts by the surface it hits. So we have dark surfaces absorb lots of insulation and they reflect little. Light surfaces reflect a lot. So things like the oceans are going to absorb a lot. Like dark colored earth surfaces, so like dark rocks and stuff. And then the things like snow and ice reflect lots of insulation. And we call this albedo. So the albedo of a surface, how much it will reflect or absorb. And this means that it controls how warm our planet gets, because the more insulation that is absorbed, the warmer the planet will be, the more that is reflected. So things like ice caps and glaciers and snow-covered ground will all reflect more insulation, helping to keep the planet cooler. So in conjunction with our atmosphere, this solar insulation, this albedo effect is really important. Solar insulation is also really important for the development of photosynthesis, which we'll talk about more in the next lesson. But photosynthesis, the development of photosynthesis, is dependent on solar insulation as an energy source. Okay, so talking about photosynthesis, early life altered these abiotic conditions. Okay, so these early abiotic conditions, things like an atmosphere that is full of carbon dioxide and methane and ammonia and water, these all changed with time. And we're talking like millions and millions of years. And this is generated by the development of things like cyanobacteria, which developed photosynthesis. These existed in shallow oceans, protected from the UV rays by the water. They captured nutrients and helped develop nutrient cycles, and they, most importantly, released as a waste product oxygen, which allowed for all sorts of more complex life to develop.